Hello, Hornets, and welcome. Thank you for joining me today. Today, we're going to be taking a look at solving these exponential inequalities. And we're going to be taking a look at the first problem today is going to be e to the 3x divided by e to the 3x minus 12 is less than negative 2. Now, when you're doing inequalities, you have to understand that there are going to be two situations that can occur. We can have a positive variable for x, and when we have a positive variable for x, when I attempt to cross multiply or multiply by the reciprocal of the denominator on both sides, then the inequality will not change. But if I'm looking at a value of x that is a negative number, then what ends up happening is the inequality has to flip when I multiply by this negative exponent to the other side. So remember, when we get a negative and we multiply two sides by a negative, an inequality has to flip direction. So the first step we have to do is find out when are we going to have a zero with this function. Now, that's going to come from our domain, and we're going to be taking it and starting with a domain statement. So we start with domain, then we use the domain to find our solutions, and then, or possible solutions, and then we look for the inequality where both of those things have to happen within the domain. That then provides us with our range of answers or our solution within a domain. Okay, so let's try this. We're going to start by saying e to the 3x minus 12 cannot equal 0. Well, if it can't equal 0, then I'm about to find out what is that value. What is that threshold between having a negative value and having a positive value in the denominator? Remember, if I get a negative in the denominator when I cross multiply, or when I multiply by the reciprocal of the denominator on both sides, the inequality flips. So we're going to add 12. We're looking at e to the 3x. We exponentiate. Make sure you do it to both sides. The power moves in front. And you'll notice we now have log base e of e, or log base e of e, which is natural log of e. And that's just 1, leaving me with 3x cannot equal the natural log of 12. I'm now going to multiply by 1/3 on both sides, and this becomes that middle ground, that threshold. So we now have two situations within our cases. Case 1, and I'm going to say case 1 is the negative. That would mean that x is less than 1/3 ln of 12. This is the first piece. Now, if I put that in, I'm going to end up having e to the 3x is greater than, because this will be a negative, and I have e to the 3x minus 12. Once again, this is when our x is less than 1/3 natural log of 12. And that will mean that I will have a smaller value and the result will be negative. So I'm now going to simplify. E to the 3x is greater than negative 2e to the 3x plus 24. I'm now going to add 2e to the 3x to both sides. This is going to give me 3e to the 3x is greater than 24. I'm now going to divide both sides by 3. E to the 3x is greater than 8. Exponentiate. Natural log of e to the 3x is greater than the natural log of 8. 3x moves in front. Natural log of e is 1. And I now take 1/3. Now, this is case 1. Case 2, I'm going to do case 2, even though once we do case 1, we now have the results for both halves. You'll see in a moment when I show you. X is greater than 1/3 natural log of 12. Putting it in, that means that my e to the 3x is going to be less than negative 2 e to the 3x minus 12. Simplifying gives me e to the 3x is less than negative 2 e to the 3x plus 24. 3e to the 3x is then less than 24. E to the 3x is less than 8 when I divide by 3. Take the exponentiation, 3x ln of e is less than ln of 8. 3x less than ln of 8. X less than 1/3 ln of 8. Now everything that we're going to do is based on our number line. So we have to draw a number line here. Now it just so happens that I've already taken the opportunity, and if I were to simply identify, we can find out what that value is. Let's just find out what 1/3 natural log of 8 is. This is going to be approximately 0.6931. That's both of these. And what is this? 1/3 natural log of 12. Well, it's obviously larger. 1 divided by 1 divided by 3, natural log of 12, and I'm getting approximately 0.8283. So I'm now going to put this on the number line. Now you'll notice it's either greater than or less than, but it is not equal to. That's over here. We're going to use a parenthesis to represent that it's not or equal to. You'll notice this value right here is 1/3 natural log of 12. So my domain goes this way, and my domain goes this way. Well, this value is here, right there. That is 1/3 natural log of 8. You'll notice it's going to go this way through, and this way through this way. Now, our goal is to find out which of these regions satisfies this inequality. So let's just choose something that's in between our 0.6931 and 0.8283. Notice the 0.8 is right in between these. So that's what I'm going to do. I'm going to put 0.8 in, right into the original, and we're going to find out what we get. So that's the fraction. E to the power of 3 times 0.8. And then we have e to the power of 3 times 0.8 minus 12. And it's either going to be less than -2 or greater than -2. If it's less than -2, it satisfies the inequality, and I know that's the region. If, however, it is, let's say, greater than -2, that's not going to be, and I'm going to look for these two. So understand, it's either going to be outside or it's going to be inside. Once again, inside or outside. If I choose 0.8 and it's true, my answer is in between. If it's not true, it's outside. All right? Now I could always choose another value like 0. Okay, 0 is off on this side over here. And if I plug in 0, anything to the 0 power is 1. So I have 1 over 1 minus 12, and that's going to give me 1 over -11. But -1/11 is not less than -2. It's greater than -2. And as a result, that is not part of my solution. Let's just go ahead and confirm. Hit enter. Oh, wow, look at that. -11 is indeed less than -12 or -2. And that's when I plugged in that 0.8. So this is my solution right in between. And I'm now going to write the solution as an inequality. 1/3 the natural log of 8 is less than x is less than 1/3 the natural log of 12. And this is my solution. Let's try another problem. This time, let's try 4e to the x over e to the x minus 7. And this time it's going to be greater than negative 6. We start with domain. So e to the x is minus 7 is greater than 0, or cannot equal 0. Let's start there. Cannot equal 0. If it can't equal 0, then e to the x cannot equal 7. Natural log of e to the x cannot equal the natural log of 7, and therefore x cannot equal the natural log of 7. Two cases. Case 1, x is less than natural log of 7. That will give me a negative. And case 2, x is greater than the natural log of 7. Well, if I'm greater than less than the natural log of 7, I'm going to have a negative exponent, and the inequality flips. And if I'm looking at the positive, 4e to the x is going to be greater than negative 6e to the x minus 7. Distributing, 4e to the x is less than negative 6e to the x plus 42, and therefore 10e to the x is less than 42. E to the x has to be less than 4.2, and therefore the natural log of e to the x is less than the natural log of 4.2. X is therefore less than the natural log of 4.2. Now this other one has to be the other half. X is greater than the natural log of 4.2, and we can show that simply by doing the reverse work. E to the 4x is greater than negative 6e to the x plus 42. 10e to the x is greater than 42. E to the x is greater than 4.2. X greater than the natural log of 4.2. There you go. Now we go to our inequality. Now I do find it easier to find out what these values are. So I'm going to go ahead and I'm going to find out what is the natural log of 7. Natural log of 7 is approximately 1.9459. Then I have the natural log of 4.2. That gives me approximately 1.43508. So this one's larger. I'm going to put it in right there, going to the right, and then going to the left. Then we do this one, right and the left. Once again, I'm confronted with two possibilities. This part here, and this part here, or this part in between. Now you have to check one of them. So I'm going to go ahead and I'm going to choose a value of 1.5. See a 1.5 smack dab in the middle. I'm going to plug it right in here and see if I get something greater than negative 6. If I do, this is my solution. If I don't, then my solution is outside. Here we go. Putting in 4e to the power of, and I'm now putting in 1.5 divided by e to the power of 1.5 minus 7, and hit enter. And you'll notice I get negative 7.11856. That is definitely less, and so my solution is in between. And I now can say that I'm looking at natural log of 4.2 is less than x is less than the natural log of 7. This is my solution. Let's go ahead and try another one. This time, we're going to do negative 2e to the 5x divided by e to the 5x minus 4 is less than or equal to negative 8. Alrighty, here we go. Now notice we could have an or equal to, so we've got to be careful. The domain is still going to be greater than or less than, but now when we find that solution, we're going to have an or equal to, which will be a bracket on one side or the other. Here we go. Domain first. E to the 5x minus 4 cannot equal 0. E to the 5x cannot equal 4. Natural log of e to the 5x cannot equal the natural log of 4. This then gives me 5x cannot equal the natural log of 4 because log base e of e is 1. And I now have 1/5. So 1/5, the natural log of 4. I'm going to find out what that value is real quickly. 1 divided by 5, ln of 4. This is approximately 0.27725. And now I go to my two cases. Case 1, we're going to use the less than. X is less than 1/5, the natural log of 4. And because it's less, it's going to flip the inequality. And therefore, I'm looking at negative 2 e to the 5x is greater than or equal to negative 8, negative 8 e to the 5x minus 4. This is giving me negative 2 e to the 5x is greater than or equal to negative 8 e to the 5x plus 32. When I add, I end up with 6 e to the 5x is greater than or equal to 32. And I'm going to divide, so e to the 5x is greater than or equal to 16/3. Exponentiate. Natural log e to the 5x is greater than or equal to the natural log of 16/3. We're now going to bring the 5x in front. Natural log of e is going to go to 1 and therefore go away. 5x is greater than or equal to the natural log of 16/3. And we take 1/5. 1/5 natural log of 16/3. And because case 1 and case 2 are linked only by that inequality symbol flipping, the only change is that our inequality flips. X is therefore less than or equal to 1/5 the natural log of 16/3. We're going to need to find out what that is, so let's figure it out. 1 divided by 5, natural log of 16 divided by 3, and hit enter. And our value is approximately 0.334795. Go to your number line. Domain is smaller this time. Let's make sure we put this in. So our domain is the or equal to. So we have larger, smaller. Be careful, these are now brackets. Notice that it can now be or equal to. This is 1/5 natural log of 16/3. This is 1/5 the natural log of 4. And I'm now going to have to choose a value that's between 0.3334 and 0.2577. I'm going to go 0.3. 0.3 is in the middle. We go to our original function, and we're going to check 0.3. Start with the fraction. Negative 2 e to the power of 5 times 0.3, denominator, e to the power of 5 times 0.3 minus 4, and it's either going to be less than or equal to negative 8, or it will be greater than or equal. Look at that. Negative 18, that is definitely less than, and so my solution is in between. Now, because I have the or equal to on the right side and not equal on the left, I'm going to have my solution as 1/5, the natural log of 4, is less than x is less than or equal to 1/5 the natural log of 16/3. Now we could do this as in set notation, right? We could do an interval notation by using a parenthesis on this side and then a bracket on this side. This is the same answer, just written a slightly different way. So we could either do it in set notation or interval notation, and those are the two options. Alrighty, Hornets. I hope this has helped you. I recommend that you continue to practice, and then if you have questions, please make sure you come in and ask. Thank you very much for watching, and I hope this helps. Please be well, be safe, and take care. Thank you, Hornets. Cheers.